What's up, everybody? Today we'll be looking at configuring CPUs. It's a very key component. So this PowerPoint will go over the exam objective. Given a scenario, install and configure motherboards, CPUs, and add-on cards. So it's going to be a part of this. This will be what you be tested on the exam, but it's okay. The CPU, as you may already know, is the principal system controller and has the greatest overall impact on system performance. On most today's systems, opportunities to improve the performance of the computer by upgrading the CPU are limited. However, you must still understand that features of the CPU architecture and packaging to assist users with selecting appropriate systems to perform upgrades and replacements where necessary to help when troubleshooting various issues. Okay, so there's mainly two types of CPU architecture. There's 32, or as it's called, 86 and 64. But it's more like 32 and 64 bit. The CPU, or simply the processor, executes program instruction code. When the software program runs, whether it be a system firmware or an OS, antivirus, utility, or word processing application, it is assembled instructions utilizing the fundamental instruction set of the CPU platform and loaded into system memory. CPU then performs the following basic operations on each instruction. A control unit fetches the next instruction in sequence from system memory to pipeline. The control unit decodes each instruction in turn and either executes itself or passes it through arithmetic logic unit, or ALU, or a floating point unit, FPU, for execution. The result of the executed instruction is written back to the register to catch into system memory. A register is simply a storage area available to different units when the CPU is working at the same clock speed as the CPU. Cache is a small block of memory that works at the speed of the CPU, or to close it depending on the cache level. Cache enhances performance by storing instructions and data the CPU is using regularly. So I had to take off my camera. But here we have the two different ones. Over the years, many different CPU architectures have been developed to optimize the process of fetch, decode, execute, and write back, while retaining compatibility with the x86-32 or i32. This x86 instruction set defines the CPU as IBM PC compatible. x86 PC processors are designed and manufactured by Intel and AMD. The 86 is a 32-bit instruction set. 32 means that each instruction can be up to 32 bits wide. However, since the early 2000s, most CPUs have been compatible running 64-bit code. The 86 instruction set has extended for 64-bit operation as the x64 instruction set. Developed initially by AMD as AMD 64 or x86-64, Intel refers to it as EM64T or Intel 64. All firmware and software, OSs, device drivers, applications must be specifically designed and compiled to run as 64-bit software. No 32 CPU can run 64-bit software, however, 64-bit CPU can run 32-bit software. A device driver is a code that provides support for a specific model of hardware component for a given operation. So this is basically the instructions of it, just the basics of what each one is. So it's like they're both 86, and the only difference is 64 and 32. ARM CPU architecture. In this slide, we look at the RM devices. To make a long story short, it's usually equivalent to system on chip. An example would be something on your phone or tablet, or even on laptops, or all-in-one PCs. These features allow much better power and thermal efficiency, meaning longer battery life and the use of passive fanless cooling. An x86, x64 platform is complex instruction set computing, meaning that it is used large numbers, say around 1,000 or relatively more complex instructions. A single complex instruction might generate multiple operations across the CPU's registers and take multiple clock cycles to complete. Reduced IC ISC uses a number of simpler instructions, say 100. This means that tasks require the execution of more instructions than CISC, which takes approximately one clock cycle. There are fewer instructions overall. RISC can make better use of the CPU registers and cache. For an operating system and hardware drivers to run on a RM-based device, they might be redesigned and compiled to use the RM instruction set. While this task is simply within the reach of OS developers, converting existing x86 and x64 software applications to run on a different instruction set is an onerous task. Another option is support for emulation. This means that the RM device runs a facsimile of an x86 or an x64 environment. Windows 10 RM-based devices use emulation to run x86 and x64 software apps. Emulation typically imposes a significant performance penalty. However, given the architectural features just discussed, the speed at which CPU runs is generally seen as a key indicator of performance. This is certainly true when comparing CPUs with the same architecture, but is not necessarily the case otherwise. Thermal and power performance impose limits to running the CPU faster and faster. Another way to make execution more efficient is to improve the operation of the instruction pipeline. The basic approach is to do most amount of work possible in a single clock cycle. This can be achieved through simultaneous multi-threading, referred to as hyper-threading by Intel. A thread is a stream of instructions generated by a software application. Most applications run a single process in a single thread. Software that runs multiple parallel threads within a process is said to be multi-threaded. SMT allows the threads to run through the CPU at the same time. This reduces the amount of idle time, and the CPU spends waiting for new instructions to process to the OS. It seems that though there are two or more CPUs installed. So you can see how this can help with your performance in games, and among other things, if you're like Bitcoin mining, you can also use that. Although that it's more relies heavily more on the graphical card. Let's see. Another approach is to use two or more physical CPUs, referred to as symmetric multiprocessing. A SMP-aware OS then can make efficient use of the processing units available to run application process on whichever CPU is available. This approach is not dependent on the software applications being multi-threaded to deliver performance benefits. However, a multi-socket motherboard is simply more costly, and so is implemented more often on servers and high-end workstations than on desktops. The CPUs used in each socket must be identical models, and the specifications must be models that support SMP. Improvements in CPU fabrication techniques lead to the ability to expand compute resources by fabricating multiple CPU cores on a single package. A single core CPU has a single execution unit set of registers implemented on a single package. A dual core CPU is essentially two processors combined into the same package. This means that there are two execution units and sets of registers. Each core will have its own cache, plus access to a shared cache. This is referred to as a chip-level multi processing. Continue with CPU. The market has quickly moved beyond dual-core CPUs to multi-core packages with 8 or more processors. Multi-core, multi-threading features are designated by NC/NT notation. For example, an 8C/16T CPU with multi-threading support has 8 cores, but processes double that number of simultaneous threads. Finally, a computer can be made more efficient and useful by configuring it to run multiple operating systems at the same time. This is achieved through virtualization software. Each OS is referred to the virtual machine. Intel's virtualization technology and AMD and AMDV provide processor extensions to support virtualization, also referred to as a hardware-assisted virtualization. A CPU with virtualization support is required to run a virtual machine. These extensions are used features of premium models in each processor range. There's also a second generation of virtualization extensions to support second-level address translation, SLAT, a feature of virtualization software designed to improve the management of virtual memory. These extensions are referred to as Extended Page Table by Intel and Rapid Virtualization Indexing, RVI, by AMD. More on CPU socket type. CPU packaging refers to the CPU's form factor and how it's connected to the motherboard. Intel and AMD use different socket types, so if you will not be able to install a AMD CPU in the motherboard designed for an Intel CPU, and vice versa. All CPU sockets use a zero insertion force mechanism. This means that no pressure is required to insert the CPU, reducing the risk of bending and breaking the fragile pin contacts. CPUs are vulnerable to ESD. Always take anti-ESD precautions when handling and storing these devices. Intel uses land grid array socket form factor CPUs. LGA form factor positions the pins that connect to the CPU on the socket. The CPU is placed on the hinge plate and then secured to the socket using a locking lever. So here we have a picture of a motherboard. This looks like it is an Intel, so this is only made for Intel. You see it has its clips, and it's much different from what AMD has. You might be able to tell the difference, but this is AMD part. It uses a pin grid array apart from the LGA that Intel uses. And its factor position depends on the underside of the processor package. The CPU is placed gently into the socket and then securely using a locking lever. The pair must be taken to orient the pin 1 on the CPU correctly with pin 1 on the socket, as not to bend or break any pins. If I were to zoom in, there's like this notch on the motherboard that tells you where pin 1 is. The same thing would be on the CPU. When removing a CPU with a heatsink and fan sealant, use a gentle twist to remove the heatsink to avoid it sticking to the CPU. Release the latch, not the hatch, securing the CPU before attempting to remove it. If reinstalling the same heatsink, clean all thermal grease from the surfaces and apply a small amount of new grease in the X pattern. Do not apply too much. If it overruns, the excess could damage the socket. Yeah, so you probably want a pea-size amount, or you could just use a thermal pad, as I've seen some people use. And with CPU types and motherboard, of course, they have compatibility issues, or which ones work with each other. The nature of a current CPU market means that there is a rapid turnover of models. Each vendor releases a CPU design with a number of architectural improvements, quite often with a new socket design. This is referred to as CPU's generation. In each generation, the manufacturer releases several models. They're either AMD or Intel CPUs, typically motherboard compatibility is limited to the same generation of CPU. The CPU must be supported by both the physical form of the motherboard's CPU socket and by the motherboard's chipset. There are limited opportunities to upgrade the CPU model while keeping the same motherboard, and such upgrades rarely offer much value. Within each generation, CPU model target different market segments, such as desktop, server, and mobile. Here we have the current designs: LGA 2011, LGA 1151, LGA 2066, so on and so forth. And for AMD, we have AM4. Desktop is shorthand for a basic PC as used as a home or in the office. The term desktop derives from a time when computer cases were designed to sit horizontally on a desk rather than vertical tower or all-in-one configurations used today. The desktop segment covers a wide range of performance levels from the budget to the gaming PC, and these performance levels are reflected in the CPU's manufacturer ranges, with multiple models of Intel Core, i3, i5, i7, i9, and AMD A and 1 up to 9 CPUs, at price points ranging from tens of dollars, i3 or Ryzen 3 series 2000s, Ryzen Threadripper Pro. Intel also uses these historic brands such as Pentium and Celeron to market budget chips. Now we're going over types of computers. We have workstation servers. The term workstation can be used in the same way as a desktop to refer to any type of business PC or network client. So you can see these mostly in the office, and they have a different OS associated with them. Usually it's Windows Workstation Pro or Enterprise. However, in context of PC sales, most vendors use the term workstation to mean high performance PC, such as one used for software development, graphics, video editing. Workstation class PCs often use similar components to server class computers. Server class computers must manage more demanding workloads than most types of desktops and operate to greater reliability standards. Server motherboards are often multi-socketed, meaning that multiple CPU packages can be installed. Each of these CPUs will have multiple cores and support multi-threading. Given the server and the raw processing power, it needs to service requests for hundreds or thousands of client systems. And again, we have to remember that the CPU also has to, well, I could be wrong on this, but I think it has to support multi-socket computing. Continue. Often feature of server class motherboards include support for tens or hundreds of gigabytes of ECC RAM and additional levels amounts of cache memory. There are dedicated CPU ranges for servers such as Intel's Xeon and AMD's EPYC brands. I have never heard of that. These ranges are also usually tied to specific supporting motherboards. A motherboard from an Intel Xeon CPU is unlikely to be compatible with the Intel Core CPU. Below we have the recent models of it. Nice to see me again. Now I have some space for the camera. This is the second to last time we have mobiles. So this could be smartphones, tablets, and laptops, or laptop slash tablet. They need to prioritize power and thermal efficiency plus weight over pure performance. Many mobiles use ARM-based CPUs as we remembered advanced RISC machines, RISC being RISC. And that was one of the previous slides. And you could go back to the video. And both Intel and AMD have separate mobile CPU models with each generation of their platforms. Mobile CPUs tend to use different socket form factors to desktop. Many are soldered to the motherboard, and Yeah, most of them are not replaced or upgradable. Thanks for watching. Hope all is well. Yeah, apparently I got a typo here, but also you can follow me on my LinkedIn. Maybe we can connect. All right, Matt. Peace. Thanks for watching.